we're going to start a unit on multiple representations where we talk about word problem situations and making tables and writing equations from those and also creating graphs. So we're going to start with this example tonight for notes, and then tomorrow in class we're going to do another example. Make sure you have your journal tomorrow in class because we're going to draw a Venn diagram in there. So this first activity talks about we're going to go to Galveston. We're going to rent some jet skis. It will cost us $30 for a deposit. Now, a deposit means that is money that you give to the owner of the jet ski, and in case something happens to it, you won't get it back. But you only have to pay it one time. Plus $45 per hour, and there's that word per, which we know means multiply. How long can we rent a jet ski if the family has a budget of $350 for the rental? So if you look at this table here, before we talk about that situation, I want to identify a couple of things. So number of hours, and then we have our process column, and we have our total cost. When we put in the number of hours, we get out the cost. So this on a table, your left-hand column will always be what we call our input. It is always going to be our X on a graph. It is also going to be what we call the independent variable, because that is the one that we do not have control over. Total cost in dollars, this is going to be our output. This is our y-axis on a graph. And then it's also going to be our dependent variable because the cost depends on how many hours we rent the jet ski. So when you look at a table, usually this process column isn't here. We're going to draw it so we can see the math that's happening. The left-hand column is always the X. The right-hand column is always going to be the Y. Independent, dependent. In science, when you graphed, you may have talked about dry mix, where you can see that the dependent is on the y-axis and the independent is on the x-axis. So that's going to help you remember that. And those are going to be some really good, important vocabulary words we discussed. So as we look at this process, I want you to look what they've written for us. It was $45 an hour, so if we have 1 hour, we're going to say 45 times 1 plus this $30 deposit. Now again, that deposit is only happening once. If we simplify this, 45 times 1 is 45, and 45 plus 30 is the 75. So we put in the 1 hour, we got out the $75. So let's try this for 2 hours. So I would say $45 times 2 hours plus the $30 deposit. So we'll see how much that's going to cost. Well, we know 45 times 2 is 90 plus 30. 90 plus 30 is 120. So we put in 2 hours, we get out $120. Our input was 2, our output was 120. So, and we're just going to make a table here to see the different number of hours and the different costs that we end up with. And then we can decide how many hours we can rent for $350. So we're going to do 45 times 3 plus 30. We know that 45 times 3 is 135 plus $30 is 165. And feel free to do the math over in the margin if you need to. 45 times 4 plus 30. 45 times 4 is 180. Plus 30 is 210. And then 45 times 5 plus 30, that's going to be 225. I do believe, yes, plus 3, 0, is going to be $250. So what we've done is we've plugged in our different hours into our pattern, and we've gotten out the different amount of money. Now, when we see just X, that means for any number of hours, how could we figure out the cost? So this is where we're going to write our equation. So we're going to just follow the same patterns. We're going to say 45. But instead of a number, we have X, which is representing our hours, plus our $30 deposit is going to give us our Y value, which in this case is cost. So what this is saying, this is our equation to represent this situation. We can put any number in place of X and see how much it would cost. So let's look at our table here on letter A. What patterns do you see? Well, I see that every hour we add, this goes up, the cost goes up by $45. Okay. Well, the reason for that is because each time we multiplied by another hour, which was $45. We also can say, plus $45 each hour increase. We can say that, the $30 stayed the same each time. We have a name for that. And you can write down any other patterns you might see. Compare the total cost to the number of hours for each row in the table. Is there a set of equivalent ratios? So what we're going to do here, and I'm going to have to squish this a little bit because I put my plus 45, is we're going to do what we call a Y-X ratio column, where we are comparing this Y value, this cost, to the number of hours. I'm just going to draw a little line here because I'm going to have to squish a little bit. So Y was 75 over 1. Well, 75 over 1 is just 75. So we're going to look here. So for the next one, I have 120 for 2 hours. Well, that's 60. I can actually stop there. If you wanted to keep going, you could. 165 over 3 is 55. The question is there a set of equivalent ratios? No. The ratio, there should be a space there, of cost over hours is not equal. How can you use this information to determine if jet ski rental is proportional? Now, we haven't talked about this word proportional. So tomorrow, that's why we need our journal, because tomorrow we're going to talk about that. So we're going to skip that one right now, and we're going to come back to it tomorrow. So make sure that we are looking at these different things. So write an equation. What was our equation? So you're going to go back here. What was the equation? Well, it was 45 times X, which was our hours, plus 30 equals Y, our total cost. Now, we could use C for cost and H for hours. We talked about using different variables. But because they give us Y and X, they want us to stay with that. How can you determine if this is a proportional relationship by looking at the equation? Again, we're going to start this because we're going to come back to that tomorrow. That's going to be in our Venn diagram that we look at tomorrow, that we draw in our journals. On the back, you have a graph. Graph the ordered pairs from the table on the grid below. Okay, I want to draw your attention to a couple of things. In our table, we said on the x-axis, our independent is our number of hours. So remember, your x-axis is here. This is always going to have your independent variable. Okay. This one, going up and down, this is our y-axis. It has a tail going up and down. This will always be our dependent variable. Always, always, always. That's why we have that dry mix. You must, when you make a graph for me, you're going to have to put labels on your axes. Okay, I need to know what those numbers are representing. Now, there is not a scale on this axis, on the X or the Y axis, so we're going to need to come up with one. Now, our hours we're counting by ones, so it makes sense for us to count by ones here. Our dollars, we had, we were adding 30 each time, and we were timesing by 45. So look for something they have in common. 30 and 45 have 15 in common. So maybe we count by 15s, or if you wanted to, we could count by 30s, and we could estimate. It's really up to you. I'm going to suggest that we count by 15. And on your hours, we'll just count by ones. And again, we need to have this label here because we need to know what these are representing. All right, I'm just going to go to 10 right now. Normally, we want to try to use as much of the graph as possible. So 15, 30, 45, 60, and it's going to take a little time to make sure. Oh, my lights went out. There we go. That you label this correctly. 90, 105, 120. How high did we go up to? We went up to 250, so we at least need to do that. 135, 150. I'm just going to skip and count every other one. We're still counting by 15s, but I'm going to label every other one and make it go a little faster. 210, 240. Alright. So what we're going to do is we're going to make a line graph. Okay? So we're going to plot the coordinates from our front, and then we can connect them if we like, but we definitely need to do dots. This is not going to be a bar graph, which I know you did in elementary school. So we're going to flip this over. At 1 hour, it costs $75. So we're going to go to our graph we've graphed before. Here is 1 hour, $75, and put a dot there. 2 hours was 120. So we're going to say 2 hours all the way up to 120. 3, 165. 4, 210. So here we have 3, 165. 4 was 210. And then 5 was 250. That doesn't look right. 255, I apologize. 255. So 5 is 255, which will be here. Now, we've used a good chunk of this. I want you to look at question number, letter A. What is the cost at 0 hours, and what does this mean? Now, we did not have 0 hours, but what I want you to do is we're going to go back to our table. Okay. And we'll just draw a little line here. We're going to put in 0 hours. So this would be 45 times 0 plus 30. Well, 45 times 0 is 0, plus 30 is $30. And that represents the deposit. So before you even are allowed to take the jet ski out, it is going to cost you a $30 deposit. So we can go back here, and we can say 0, 30. So what was the cost at 0 hours? $30. What does this mean? This means that that's your deposit. You have to pay that $30 no matter what. What does 6,300 on the graph mean in words? So we can go here. 6